time talking about requirements, which is actually a very important topic. So what the heck, let's spend a little bit more time talking about requirements, because ultimately, as you move out into the world, you know, we all go, wow, design something I want to do, it's something I truly enjoy, I feel it's really, truly using all of my technical skills, and congratulations. But you'll really spend a disproportionately large amount of your time dealing with requirements. And the reason is because requirements is where it all starts. Okay? And all the money that's going to be spent, all the time, the energy, and the effort, it all starts with the requirements. So for a firm or an organization that you go to work for, they're a little bit crazy about requirements, because they know if they can get the requirements right, the project or the design activity that comes after it, that will be money well spent. If you hurry through the requirements, if you say, I just want to do design, just get, yeah, we'll do something like that, it'll look like that, we'll go from there. If you race through that, you know exactly what's going to happen. You're going to get halfway through and go, oops, forgot that. Or oops, that's not going to fit. Or something along those lines. I mean, one of the better examples that we could possibly have here is cooking. I love to cook. It's great, it's fabulous. If you got to have a hobby, that's the kind of hobby because you can hide all your failures pretty easily. The challenge is that I do actually a very poor job of actually reading the recipe before I start. And there has been more than one time that I've gone, fantastic, I'm going to make this recipe tonight. I'm out there in the kitchen, I've got it all laid out, I take a look at it, it says, hey, put all these ingredients together and marinate for 8 hours. Man, I really should have read that, because I'm not going to be able to do anything about that. That's just part of the recipe, right? So, much the same as with a recipe, with a design type of activity, you spend your time up front, you spend your time with the requirements, it's going to make your life a lot easier later on. It's a hard lesson. We don't like it. That's not information we want to hear, but that's the way the world works. Okay, so we talked about this a little bit last time. We talked about actually developing the requirement specification. Remember, although it's a document, it may be an electronic document these days, but no matter what, it's a document. It contains both the marketing and the engineering requirements. That's what goes into a requirement specification. And it doesn't just exist by itself. What you're really creating here is a communication tool. Because remember, you're probably part of a team. You're part of a group of people who are coming together to design and potentially to build your blue widget or your red widget or whatever the heck your company has decided to put together. And really, when you've got multiple people, it can be like a game of telephone when you're growing up, right? You know, so one person hears one thing, another person hears a different thing, and if you go off to design and build it, fantastic. If you all build your subsystems and parts, when you come together, it's just not going to work together. So the requirements document is how you make sure that everybody is on the same page. That's the key thing. But another key part that has to be in the requirements is justification for why you decided to do something. So it might be really clear to you why you decided to make something that was this big. Okay? Everybody agrees. Everybody says, yes, it should be this big. You go off, you start to get parts together, you start to put your design together, you know, 2 months down the road, you're going, man, it's going to be almost impossible to make something that's that big. Why don't we make it just a little bit bigger? Okay? Because I can't think of any reason why it has to be that big. If you haven't identified what your justifications were, everyone's going to sit around the table and go, well, then just make it larger. That's no big deal. Right? When in reality, there may have been a very good reason why it had to be whatever that size was. If you don't write it down, 2 months, 3 months, a year later, people aren't going to be able to remember why. They will make changes, and that can come back and bite you. All right? Experience is all part of this process. Right? First time you ever put together a requirements document, that's going to be the worst requirements document you've ever created in your life. Second time you'll do a better job, third time you'll do a better job, and so on and so on. You've got to understand that requirements documents aren't something you put together and then put up on the shelf. They need to be a living, breathing document. You become smarter as part of the design process, and also you become smarter as you go from requirements document to requirements document throughout your career. There is a question of validation that you always have to be asking yourself. Okay? So when you put all of these things together, when you put the marketing requirements, when you put the engineering requirements together, you've got this document. And the question is this a valuable thing or is it a hunk of junk? Congratulations, you all spent your time trying to figure out how big it should be, how much power it should have, what kind of chips should go into it, what kind of features it should have. At the end of the day, Do you have the best requirements document for a groundbreaking typewriter? I mean, because you might, and that might be the coolest typewriter ever invented, but who needs a typewriter these days, right? Why do you waste your time? And why should you go ahead and actually build or spend time creating it? It's a typewriter, right? We don't need those anymore. So there's a validation question that you always have to be asking yourself. It's a lot more general in scope than what we talked about as far as verification. Verification is making sure that each one of the individual requirements is correct. Validation says, hey, should I really do this whole thing, in the first place? Okay? Validation is done by verifying a design. You've got to figure out if you've got your traceability and your verifiability properties met. And overall, is the thing complete? Do you have all the requirements in the document that you're going to need? So, requirement specification actually has two major components to it. The first one is the marketing requirements. What do your end users want? Okay? We talk a lot about customers, but depending on what type of design you're working on, your customers might be another department. Okay? It might be another part of your company. It might be another engineering organization. It doesn't have to be somebody hanging out in the aisles at Best Buy. It's just who's ever going to receive the product that you're putting together. The other half of the document is engineering requirements, right? And it turns out that those two have to live together, right? So marketing requirements by themselves are completely useless. Engineering requirements by themselves are completely useless. They are only valuable when you have them together, which is what the requirement specification is all about. There has to be a mapping between your marketing requirements and your engineering requirements. Remember, they don't exist by themselves, and there has to be a linkage between the two of them. Okay? 3 different ways to map them, and we'll be talking about these one-to-one, one-to-n, and m-to-n. And at this point in time, you might be going, oh, God, this seems a little dry, seems a little boring. I want to design circuit boards and wires and chips and op amps, and yeah, that's what it's all about. Hang on half a second here, because this is a little bit of career advice, and you're more than welcome to take it or not take it. It's your call. So you've got a couple of choices in your career. Okay? One of the choices is that you want to go off and you want to live in a lovely little cube at some company, and people will show up and they will hand you designs, and you will crank out a design and you will give them the designs back, and that will be your job for, well, Mr. Samuel's not here. How long's your career?
45 years.
45, thank you for filling it. I greatly appreciate that. Yeah, so for 45 years, you'll sit in a cube and you'll do that. And if that's what you want to do with your life, congratulations. You have hit nirvana right off the bat. If you want to go on beyond that, if you'd like to be a little bit more of a superhero, here's a little tip for you. So in the world that you will be occupying, there's going to be a bunch of people who understand the marketing requirements for anything your firm decides to do. Okay? Marketing requirements are actually pretty easy. You go out, you talk to the people who are going to get it, you write it down. It's relatively easy to understand that. There's going to be people who understand the engineering requirements. Okay? And they will sort of look like this. Okay? It's because they love technology. They really think technology is fantastic. They love creating things. They love doing designs. They are going to be up to their necks in engineering requirements. And they're going to know more about whatever the underlying technologies are than you ever will in your life. Just because they live it, they eat it, they breathe it. Okay? So you've got 2 groups that you're going to be interacting with. People who really know the marketing requirements and people who really know the engineering requirements. Your true career opportunity is if you can bridge these 2 worlds. So if you can understand the marketing requirements and you can understand the engineering requirements, that's going to make you a very special person, because there's not a lot of people like you out there. As a design project goes on, what's going to happen is they're going to run into problems, because every design project does. And there's going to be some technical consideration that's really hard to do. Okay? We can't store that much video, or we can't communicate over that great of a distance. What would happen if we change that engineering requirement? And the engineers are going to sit around and go, I don't know, or it shouldn't matter, right? if you're able to relate that engineering requirement back to the marketing requirement and say, stop, this is going to be used by this type of customer in this type of environment, so it really does matter that we're able to communicate over that distance or we're able to use that amount of power. So don't change it. Or maybe you can change it a little bit and it'll still work for them. Any one of those ones are fine. Same thing with the marketing requirements. It may turn out that while you're working on a design, one of your competitors releases a product that has a particular feature that you were planning on implementing. And the marketing guys may come back and say, hey, guess what? Turns out customers don't really value that. They're not using that feature at all. Maybe we should drop it from our product. We shouldn't bother to implement that as part of our design. What would the impact of that be? The engineering guys are going, I don't know. The marketing people are going, we don't know. If you know, or if you're able to relate the marketing requirement to exactly what the engineering impacts of it are, and say, hey, look, this, and this requirement would go away if you didn't have to do that feature, then all of a sudden you're valuable. Because you've got a foot in both worlds, right? You've got a foot in the marketing world, you can speak customer speak, and you've got a foot in the engineering world. You're able to understand the technical part of what's going on. There's not a lot of people out there who have that skill. There are a lot of marketing types, there's a lot of engineering types, but there's very few people who can actually move between both worlds. So, little career advice there, do whatever you want. But if you can understand both of those, and if you can understand how they relate to each other, your career is set. You're valuable to any company that you work in. Alright, so let's talk about this. Hey look, it's an audio amplifier. Woohoo! So this is actually a real audio amplifier. As you take a look at this, you should notice that there's two key features, two key physical features on an audio amplifier. What are they?
Heat sinks.
Heat sinks. Are they little heat sinks?
They're very large.
They're very, so basically this thing's cranking off some serious power. They got to get rid of some heat, right? So what does an audio amplifier do? You may know, but no matter what, I'm going to tell you, just in case there's anybody here who doesn't know. If you have a microphone, so how does a microphone work? Once again, back to my son's little electronics kit. It's actually pretty simple. You and I speak. When we speak, we move air. That air hits a filter on this. It causes it to bounce back and forth. The bouncing back and forth of the microphone filter causes a very weak electrical signal to vary. Basically, that's your sound waves being encoded in electric format. That's actually going to be sent down to an amplifier. If you want to do something crazy like drive a speaker as part of a PA system, that little current that's coming off of the microphone is not enough. You really got to jack that up. You got to amplify it. And that's exactly, in its simplest form, what an amplifier does. Now the trick with this is that if you don't do this well, you're going to introduce a lot of noise. So my beautiful voice that goes into the microphone is going to get augmented by hums and whistles and pops and burrs and stuff like that. So if I buy a cheap amplifier, it's going to distort the electrical signal. If I buy a high-end amplifier, the purity of my voice will come out from the other end and go out through the speaker. So depending on how much you're willing to spend, and depending on the design of the amplifier, the quality of the output signal will be more true or not true. So there's actually, what are the characteristic parameters for an audio amplifier? Are generally frequency, response, gain, noise, and distortion. Just if you had to sort of lump it together. So we're going to be talking about the requirements for one of these. Is there anything else? Oh, how do you test an amp? So great, so here's an audio amplifier. How would you actually test the quality of an audio amplifier? You take a Lady Gaga song, and then you, no, that's not going to work.
Do a frequency sweep and measure.
Ooh, that sounds sort of complicated, but okay, how would you actually do a frequency sweep? A bunch of frequencies?
Just do a sine wave sweep.
Okay, you're real close there. Okay, so right, all right, so that's the key. So what you do is you take a sine wave that you know, you put it in, and what you should get out the other end is that exact same sine wave, right, with one change. What's that?
Higher amplitude.
Exactly. So if you get back perfect, congratulations, you got a perfect. You'll never get back a perfect one. It's always going to be altered somehow. But if it's modified just a little bit, then you've got yourself a pretty good one. All right, so let's see what we got here. So one-to-one mapping, arguably probably the easiest type. So what do we actually have here? So the marketing requirement for our audio amp is should have excellent sound quality. That's cool. Now is that in the words that you would expect a customer to have? Yeah, there's not a lot of technology going on there. Hey, it's got to sound good, right? So now we go to our engineering requirement, and what we're talking about here is total harmonic distortion. Basically, what does it sound like when it comes out? Is it still that pure sine wave, or has it actually been modified? It should be less than 1%, which is actually pretty good for an audio amp. And the question is, well, why? Why? So we go to our justification, and what we're really talking about is competitive benchmarking. What's available in the market? And what they're saying is, yeah, that sort of fits. Down here, we should have high output power. Okay, that's cool. So basically, you're able to drive some serious sound. Should be able to sustain output power that's greater than 35 watts, and with a peak value greater than 75 watts. And once again, what we're really talking about here, interesting enough, is in a car. So we're not trying to fill a concert hall or anything like that, because the numbers would be different. But when we're using this audio amp in a car stereo system, that's about the right numbers to have there. Marketing requirements are obviously short statements that are going to describe the end user needs. Our engineering requirements, notice they seem to have values, right? Because we want to make sure that our engineering requirements are quantifiable. We can actually bound it and say exactly what's being asked for. Justification indicates why it's a realistic type of requirement to have. That seems like a good thing to have. Interesting enough, if I make a change here and this changes, or if I make a change here and this changes, simply that means we have a one-to-one mapping, right? Those are linked together, they're joined together. If you make a change in either one of them, then you've got proof that you got something going on. All right. Remember last time we talked about our buddy Mr. Roku. What does the Roku do?
Everything.
It's fantastic. For about 80 bucks at that. Fantastic, right. So it takes what? Basically off the internet, take for example, Netflix, and then takes it and displays it where? On your TV. Fantastic. All right. So if we're going to talk about the Roku, if you were in charge of coming up with some requirements and stuff like that, so what do we have here? Oh, look, it's a partially filled out table here. This would actually be a great midterm. Well, whatever. Okay, so our marketing requirement is the Roku will allow the user to cause a hard reset by physical action. You know how that is. It gets messed up. You want to reset it. There has to be something. So if that's my marketing requirement, what would an engineering requirement be?
A reset button. I can take the reset button that clears
Okay, so
clears data from the hard or the memory storage devices or something.
Remember, engineering requirements are short, concise statements. So we're getting there. All right. Now what's interesting is you said button, right? What else could it be besides the button? Switch, right? I mean, I don't know if one's better or the other, but certainly you want to be clear about that, right? All right, so button. And what does it need to do?
Reset.
Reset. And how would you reset an electrical device? Kill power, right? And maybe you would kill power for a particular amount of time. I mean, 5 seconds or something like that. And then maybe automatically restore power? So it's almost like you break the circuit and restore it, something like that?
It's going to be able to discharge also.
Discharge, so the circuit has to remain broken for a period of time that would allow the rest of the components to come down, right? And in fact, I think...
So how do you say all that in one concise statement?
Well, it's interesting. You may not be able to say, first off, run-on sentence, of course. I mean, that's pretty simple. But, that actually might be something that you'd have to break up into multiple sentences, right? So, good point. A couple different ways to go on that one. So, let's say that we have an engineering requirement that says the Roku will buffer up to 1 second of video. What kind of marketing requirement?
Uninterrupted streaming.
All right, so I don't want to see, if it was interrupted, what would I see?
Stop.
Choppiness, I could go to a blue screen, anything that would interfere with my visual enjoyment of whatever movie I'm watching, right? Right, okay, there you go. And maybe this would have something to do with pausing or something like that, right? So something along those lines. And would there be a justification for this? Why would you go to the effort of putting it in 1 second?
We would want to watch it if it's going to stop all the time.
Okay, so it's overall quality for the user experience, right? All right, so what else we got here? We've got the one-to-N mapping. Okay, so let's talk about this. So this, in all honesty, one-to-one, easy to understand. I think we all get that. There's no problems with that. You'll never see that. Life doesn't actually work out that way. That's a little bit too easy. So one-to-N is actually pretty straightforward here. What we have is probably, for example, one marketing requirement. Okay, and it's going to blow up into multiple engineering requirements, just like we talked about with that physical reset switch. This is a little bit more realistic. And I apologize, this actually isn't the auto amp. This is just some other device that's measuring the effects of temperature variations on optical power systems. Has to measure it, power output. in that particular temperature range that the device is, and then down here it has to maintain its temperature accuracy to within plus or minus 1 degree Celsius during all the tests. Okay, so one marketing requirement blows up into two actual engineering requirements, and then we have a justification for both of these. Once again, it's sort of based on what other products actually do. This is actually much more realistic, which is also sort of interesting because if for whatever reason somebody makes a change to the marketing requirement in your life, it can have a huge ripple effect, right? I mean, this is just 1 to 2, but generally it can be huge, right? There might be a whole section of requirements. So, and that happens all the time. So as you're halfway through your design, boop, somebody changes something and all of a sudden you find yourself in a bind. All right, so 1 to N for Roku. All right, so here's our marketing requirement. The Roku will allow the user to control it remotely. All right, so what would it be an engineering requirement that would come out of that marketing requirement?
The frequency that the reporters operate.
And what, would that be the depth laser frequency? What kind of frequencies are we expecting?
Infrared.
Infrared's one. Now I have a, what do I have? I've got Dish at home, and it actually supports 2 different ones. So one's infrared. What else? Or what is the other choice?
Camera.
I think infrared and RF might be the same. Well, no, I'm sorry. Okay, no, you're right. All right. So yeah, so you can got 2 different ones there.
Some is utilized on Bluetooth now.
That you would have to be sort of close. So I'm not sure what the range of Bluetooth is. It's not that network.
30 feet.
30. I would think that that would be close enough if you're in the same room, right? Because I don't want to be, you don't be Roku from the. Okay, that's okay. All right, so we've got frequency. What else? What other engineering requirements? Well, that's it. Pretty much.
Let's do a smaller mode.
Now, where's my battery, guys? Where's my battery, guys?
Well, I mean, we'll wait till we get there.
Okay, all right. So the power cord should coil up around this, so that I can
One step at a time.
Okay.
Yeah, we're trying to take this whole step here.
I understand. Don't rush yourself.
Don't watch yourself, exactly.
Just saying. Give me another one.
Encoding of the remote commands.
Oh, you know, that's actually an interesting one, right? So if you guys have ever gotten, a generic remote control, what do you have to do to get that generic remote control to work on your TV?
That's a mode.
Yeah, you gotta sort of mess with it and put it in programming mode. Or
Wait, if it comes with the Roku, it all reset up. So it has to be idiot proof, is what you're saying.
punch in a 3-digit
That's
code
fine.
and hit pound or something.
It has
Okay.
to be X by Y by Z size.
Has to be compatible.
Yeah.
All right, so
I
we'll go with
was
that.
trying to give it dimensions.
Okay. Well, you know, you bring up a good point, and actually that might be a different marketing requirement. I would like the remote control to not only control my Roku box, but also control my TV, right? Because if I'm going to watch my Roku, I'm also going to be watching my TV.
Yeah, why have two remotes,
Yeah.
I mean, that's just,
That's all right. Any other engineering requirements that would flow from the concept of I'd like to be able to remotely control my Roku?
an iPhone app.
Buttons is okay, but that's not really an engineering requirement. I mean, that'd be more
Well, I
like.
mean, if you have one button, all it does is turn on the power versus you actually control.
We bring up an interesting point because you're talking functionality, right? You must be able to rewind would be over here, right? Over here, you would say what?
Fast
Rewind. Must be able to command. Well, you probably have something like support the following commands. I don't know, but I suspect there's probably a base standard thing of some sort for remote controls because there's, you know, they're all common, right? Start, stop, play, go back. There's got to be some sort of standard for those.
Hey, your Hans is here.
We celebrate the arrival of everybody. That is fantastic. Okay, so we're good with that. All right, let's move on. Here we go. Oh, hey, we're to the big day. So M to N. Now, this is actually really, arguably, the most general case for requirements. This is what you're going to see all the time. So it could be one marketing requirement goes to a bunch of engineering requirements. It could be a bunch of engineering requirements go to a bunch of marketing requirements. You can switch back and forth. Once again, we're back to our power amp here. You can see that we have marketing requirements. We just decided to call them by numbers 1, 2, and 4. They go to total harmonic distortion. We've got a justification for it. What's interesting is that requirement number 2, which drove those engineering requirements, is also down here. Requirement number 2 is also driving this engineering requirement. And once again, this is the way life actually works, okay? There's not neat divisions between these different requirements. They all sort of seem to spill over into each other. So that's what you're going to actually see. Everybody talks to everybody else. So let's go to our Roku example. What do we got here? So I've got a marketing requirement. it's going to support a video signal output. So what kind of engineering requirements could that go to?
Comply with multiple video standards.
With which type?
Multiple video standards.
I think so. So what are the possible multiple video? What type of video standards could we talk about?
RCA, HDMI,
Excellent.
video,
Excellent.
VGA.
What is it? The PAL, right? If we want to go international. Probably done.
HDMI.
HDMI, right? Right? Our high def stuff. All right, so that's good. So you can see a whole list showing up on this. The Roku will simultaneously support HDMI and an audio cable. Well, that's weird. I wonder why that. What's the marketing requirements behind that? Surround system. So if I want to basically drive something else, I must be able to support my home stereo system, must be able to support something, right? So you can see multiple marketing requirements could flow into that one, right? Oh, so there we go. That's just a sweet little box. All right. So now let's move on. So you find yourself with a bunch of different requirements. You've got your engineering requirements and you've got your marketing requirements. And one of the key things that you're going to need to be able to do is to understand how those relate to each other. Because when you go tinkering, when you make changes to an engineering requirement, there's going to be a ripple effect into the marketing requirements. And likewise, you start messing around with the marketing requirements, there's going to be an impact on the engineering requirements. And as we talked about at the very beginning, all requirements are not created equal, right? Some are more important than others. And what you really need is you need a tool that's going to allow you to understand how these relate together. All right, so let's take a look at this. So first off, we've got polarity. So this is the marketing requirements here. These are the engineering requirements across the top. So the polarity says basically, if I increase it, does it make the product more valuable? I hope that's it. So sound quality, if it goes up, does it make the product more valuable?
Yes.
Okay, how about high power?
Yes.
Yeah, of course. Yeah, bring it up. How about if I make it easier to install?
Sure.
More valuable? And if I boost the cost? No, so that's bad. So that's a
More
negative.
valuable than cost.
Total harmonic distortion. If I boost the distortion, the value of the product goes down. Okay? Output power? Yeah, more power is good, right? Efficiency goes up. If I boost my install time, the value of the product goes down. What is it? Dimensions. If I make it bigger and bulkier, the value goes down. And of course, cost, as with everything, you boost it, the value goes down. So that's your polarities. Okay? So now what we have here is correlations. Note that if there's nothing here, there's no correlation between the marketing requirement and the engineering requirement. There's just no correlation. Okay? If there's a single arrow, there is a correlation. If there's a double arrow, it means there's a strong correlation. So let's take a look and see what we have here. Sound quality and total harmonic distortion. Okay, so first off, there's a strong correlation between those two. And what we're looking at here is if we boost, let me make sure I say this one correctly here. The goal is to increase sound quality and to decrease the total harmonic distortion. So there's a strong correlation, a strong positive correlation, because decreasing the total harmonic distortion will increase your sound quality. So we're good with that. Sound quality and output power, there's a inverse or a negative correlation between those. Because if I boost my output power, my sound quality is going to tend to go down. Because I'm going to get a lot more artifacts put into that. And you can see over on cost, pretty much anything you do. So sound quality is good, but it has a negative correlation with cost because to get better sound quality, am I going to have more expensive parts, more engineering, more components? So it's a strong correlation. I can get better sound quality, but it's going to have a negative impact on the value of it. All right? So just by taking a look at this, you can see very quickly where there are linkages. And if somebody comes along and says, hey, I think we really got to boost the power on this, you can come back over and you can take a look at what the impact on the engineering requirements is going to be. Does that all make sense? Let's go on. All right, so engineering trade-off matrix. So what we just talked about was how the engineering requirements relate to the marketing requirements, which is good to know. Now, even within the world of engineering, the question is how do those engineering requirements relate to each other? Because even as you're working through the design, even as you're working through the individual components that you have to work with, there's going to be trade-offs that you're going to have to make. And the question is if I make a trade-off on this, what's the effect on the other components of the system? So let's take a look here. Clearly we block out all the relations with themselves. Harmonic distortion to harmonic distortion, we don't care about that. But let's take a look here. So it's harmonic distortion to output power. You can see, once again, there is a correlation. Okay? And as you boost the power, the total harmonic distortion is going to go down. Once again, it's engineering on this side, and you can see the correlation. I think we really only have two positives. So output power and efficiency, rock and roll, that's fantastic. And I think we have, efficiency and dimensions. So if you do a better job of using the power that you're given, then you can make all of your components smaller because you don't have to deal with all the heat loss that's going on there. So that's it, and of course everything has a negative correlation with cost. You can make the entire product better, not a problem with that whatsoever. It's just that it's going to cost a lot more if you do. So by taking a look at this, you start to understand, if I make a change in any one of these engineering requirements, exactly which other engineering requirements it's going to have an impact on, which is a critical thing to understand, because people are always going to be tampering with your requirements. They're always going to be making requests to make changes to the requirements that a week ago, a month ago, everybody agreed to. All right? Competitive benchmarks. Okay, when you're creating your audio amplifier, it turns out that you don't exist on a separate planet. There's other companies out there that are doing exactly the same thing that you're doing. When they bring their products to the market, you can buy one, you can take a look at it, you can take it apart, and you can compare their product to the one that you're putting together. So in our world, the folks at Apex Audio and Monster Amps have come out with a virtually identical product to what we're going to do. So let's take a look at it. Let's compare it on 4 different bases. So the harmonic distortion over at Apex Audio, they've got a 0.05% harmonic distortion, which is actually really, really good. Monster Amps got a 0.15, and we're at 0.1. Woohoo! So we're not as good as them, but we're better than them. Same thing, 30 watts is what they need. They need 50 watts, suckers. We're at 35. So we're in number 2, right? Let's keep going down the list. Efficiency, they're at about 70%, which is really good. Monster Amps at 30%. We're about 40%. Apex Audio, man, they're charging through the roof. They're at $250. Monster Amps trying to get $120 out of people. We're only asking $100. Okay? So what this means is you can take a look at it and go, oh, from an engineering point of view, these are the values you need to know. What you're going to discover, and what I have discovered in my career, is that if you let engineers run the world, we will over-design every product that we create. We will make it fantastic. The world would be filled with Mercedes-Benzes if engineers ran it, right? Everything would be machined to super tolerances. It would be fantastic, and everything would cost $1 million. There would be no question about that whatsoever. So what this shows you is that we sort of have a feel for the values that we need to have, right? If you want to have a competitive product, this is sort of the high end. I'd say this is the low end, and we're fitting sort of in the middle, right? If we want to go for the high end, we know what values we need to go for. If we're comfortable being in the middle because we think 250 is more than most people are going to be willing to pay for an audio amplifier, then we're exactly where we should be. But no matter what, these are your target values, and these are the values that then need to get worked into your requirements, right? Your competition has been kind enough to show you exactly how good of a product you should make. You shouldn't be making a perfect product. Unless you're working for NASA, unless you're sending people to Mars, then make a perfect product. But if you're not doing that, then in this case, make a product that's good enough for the situation that you're in. The house of quality. This is just so cool, I had to share it with you. All right, so we've talked about a bunch of different ways to compare a bunch of different requirements. House of quality, you have seen all of this before. The house of quality just brings it together into a single diagram picture, whatever the right way to say it is. So over here we have our marketing requirements. Over here we have our engineering requirements. You recognize this is the correlation between the marketing and the engineering requirements. We've seen that. Up here, what we have is, and this is why they call it a house, because it's got a roof, right? So you have to call it a house. This is actually the correlation between the engineering requirements. Remember we had that in a separate table, okay? And then down here on the bottom, these are actually the values that we've picked out of our competitive benchmarking, right? So in a single diagram, if you shared this with everybody else on the design team, suddenly everybody would be able to speak the same language, right? They'd be able to go, oh, I understand what our targets are, what happens if we go monkeying with the different marketing and engineering requirements, and I understand that within the engineering requirements, which one of the engineering requirements are related to each other.
I don't understand roof.
The roof, okay, that's fine. So let's go back to here. So the roof is this, okay? So if I do this right, output power and efficiency is a positive correlation. You with me there? All right, so let's take a look. Output power and efficiency. I hope I can do this right. So I think it goes like this. So my drawing might not be all that great,
Okay.
but you get the gist of that. This was designed to show you efficiency and dimensions. Remember we talked about that one? It's a positive correlation. All right? If there's any unclarity, it's probably due to the artistic quality of the actual house itself. But basically, it's taking a matrix and trying to make it an angular sort of thing. Everybody cool with house equality? All right. So let's talk about constraints. So what are constraints? Limitations, right? You do not have a blank sheet of paper when you're creating a design. You work within a real world. That world has constraints such as cost, et cetera, et cetera. So let's talk about some of the constraints that you're going to bump into when you're creating a design. For example, health and safety. So what could a health and safety constraint be?
Can't exceed a certain temperature, right?
Right, exactly. Or generally what it's going to come down to is if somebody's using this product, something bad should not happen to them, right? If you're dealing with electricity, what's the number one thing you don't want to do to somebody? Show them. Right, exactly. So here's an interesting question. We'll see if you guys know the answer to this. So, what kind of voltages are problems for humans?
Doesn't matter.
Okay, what kind of currents are problems for humans?
1 million, 30 million, 1
It
million.
depends if they're wet or dry.
All right, so my understanding, and I will grant that I may not be perfect with it, I think there's actually two ranges, right? There's a very low range, where if you get zapped with it, it's going to mess up your heart, basically, right? Because you're an electrical creature by nature, and it's a very small milliamp type of
35,
thing.
I think
It's
it's
something.
Once it gets to about 10 million.
Right, if you're having a heart attack, what do they do?
They shock you.
Right, exactly. So basically, if you have any shocks that are in the same range and you're not having a heart attack, you can mess things up, right? And then I think there's a safe range where you're going to injure yourself. You will burn yourself, but you'll be fine. And then I believe there's a range that goes up from there that you're really going to smoke yourself.
They just explode.
Yeah, you're basically going to,
Lightning.
because you're a very poor resistor for a very brief period of time, right? So I think that there's a middle area where you still injure yourself, but you don't die. But I believe there's a low end where you die, and a higher end where you basically burn yourself. I don't know, if you're going to be working with electricity, it might be important to know what those numbers are. I'm just saying. But.
Just avoid it in general.
And don't stand in the kids' play pool whenever you're doing any sort of electrical stuff. All right, what else we got here? We've got environmental. So what kind of environmental constraints would you anticipate being applied to one of your designs? What is environmental? Is it like, make the earth green?
Yeah.
No! Environmental has to do with where your product's going to be used, right? Where's your design actually going to be used? So give me an environmental constraint. Dry, I think that's actually very important. What else?
Temperature.
Temperature, exactly. If it's going to be in a freezer, it's a freezer monitoring system, it best be working when it's cold out, right? Okay, likewise, if it's, to measure the desert temperature, it better work when it gets really hot, right? Excellent. For example, of our audio amp, we said it was going to work in a car, right? Well, cars have different sorts of temperatures. In Florida, if you shut the door in a car and go away for an hour on an August day and leave it in a black parking lot, it's going to get warm in that car, right? No matter what, you don't want your audio amplifier to melt. Make sure whatever soldering you use on that is some rugged stuff. All right, cool. What else we got here? We've got ethical and legal. Yes! We put ethics into it. So what kind of ethical and legal things do we have? For your design, should not accept gift baskets from suppliers. Obviously, we know that one. But what else?
Well, you have some materials that aren't legally used.
No blood diamonds should be used. I mean, fundamentally, that's exactly correct. So an interesting thing, and probably the most common one, is if you create a design, the question is are you stepping on somebody else's patent? Right? Does somebody else have some intellectual property that they've patented or gotten some sort of legal protection for that all of a sudden you're using in your design, right? So something to consider there. All right, so what else we got? We got economic. What would be an economic constraint? This one's simple.
Cost.
Cost. Does it cost too much? Hey boss, look at my audio amplifier. You can have one of these for 10 grand. Well, first off, congratulations. It's a great audio amplifier. Way too much. We're not going to make it. All right. Manufacturability. What would be a manufacturability constraint?
Is there a factory that can manufacture tomorrow?
Exactly. Yeah, you know, if you're talking about a circuit board, and especially these days, is it a multi-layered circuit board? The size of the circuit board could be a huge issue, right? Does it fit on a single board, multi-board? Is it a layered board? So those are all very good considerations. Sustainability. Is that more of that tree hugging stuff?
Yes.
Oh, that's wonderful. No.
Supply part's gonna run out.
Exactly. So the question is how long are you going to build this product for? How long should it last? Once again, we're engineers, right? So we design a product to last how long? Forever?
45 years.
Exactly.
You can't make money like that.
My question is, so here's an interesting question. So, quick show of hands. Who owns an Apple, iPhone, iPod, whatever? That's it? Just a few? Really? All right. How long is that going to last? Or how long should that last? How long are you going to have it? Maybe that's a better question.
Until Steve Jobs quits.
When you're done.
Yeah. You know, it's interesting because you're only going to, 3 years would actually potentially be a fairly long period of time. You know, depending on your economic situation, of course, you'll keep it longer. But you know, if you could, you trade up, right? Because now the iPods are passé. Now it's the iPod Touch, right? And then who knows what they'll have next year and next year and next year. So if I designed an iPod to last for 20 years,
You get fired.
yeah, that's crazy. You know, congratulations. I mean, that's really, but that's, all right, so there we go. All right. Political. What could your political considerations be?
Embezzling money.
That's true, but what does that have to do with your design?
What's the company that Billy of?
Cylindra?
There you go, that's the one.
Yeah, but did that have anything to do with, oh, that's just poor management, but, all right. Political, interesting point, if you're working on anything having to do with medical, you're going to have to get FDA approval. You're not going to sell anything before you do FDA approval. Another interesting thing, hearing aids. Huge engineering market for hearing aids. Do you know how much a hearing aid costs?
A lot.
It's about $3 to $5 grand for a hearing aid, right? And what's interesting is I think 80% of the people who have hearing aids were at one point in time in the military, which is interesting. It makes sort of sense to what's going on. But what it also means is that the single largest purchaser of hearing aids is it's not the Department of Veterans Affairs, but it's whoever provides medical service to the U.S. military. And basically, if they don't approve, if they don't agree to buy your product, don't even bring it to market, right? Because they buy more hearing aids than anybody else. So you got to get their buy-in. You have to meet their needs, their requirements, their price points. Otherwise, you won't be selling that to anybody. All right. Last one is social. Well, so what kind of social constraints? What the heck? When it's on Facebook, it's all good. So what kind of social constraints could be on your design? Don't offend anybody. No gratuitous language. I mean, here's one. Your health screens that you've built into it need to be in English and Spanish, Mandarin, whatever. Right? All right, so constraints are one, and then finally, if we want to wrap this discussion up, let's just talk about standards here for a brief moment. So standards come from a lot of places. In your life, they're IEEE standards. You're going to be just swimming in IEEE standards, because they get standards for everything that you're going to encounter. There's 3 different ways to use standards. At the user level, it's the highest level, and you don't actually have to know about the standard. So for example, if you're designing a device that's going to have Wi-Fi support, are you going to have to know the Wi-Fi standard?
No.
No. What are you going to do?
Hire something.
You're going to buy a module, right? The Wi-Fi module. Plug it into yours. Now you're going to have to know something, right? You're going to have to know the ins and outs of that particular module, of course, right? Maybe read a driver for it or something like that. But you're not necessarily going to have to know the Wi-Fi standard itself, because you're just using a component that has it built in. Number 2 is going to implementation level. At the implementation level, that's where you're actually potentially writing things like drivers for software and stuff like that. You're going to have to know the standard at that point in time. Because you're actually using it or coding something that's going to have some reliability based on how that standard operates. And the final level is what we call the development level. And this is where you're in a cutting edge situation, where perhaps the standard hasn't quite been nailed down. An example of this would be, so the current bestest wireless standard out there for cell phones is what? What's it called?
4G.
4G, but the technology underneath
LTE.
CDMA isn't quite 4G.
It's WiMAX.
Keep going. It's got 3 letters. It begins with an L.
LTE.
LTE, right, which is long-term evolution. Okay? CDMA 2000 maybe, or WCDMA, I'm not quite sure about that one, but no matter what. LTE is the big one right now. But LTE is not the end of it. There's another we'll follow on standard, of course, called LTE Advanced. And in LTE Advanced, if you're in a fixed situation, you potentially get up to 1 gig of bandwidth. And if you're in a mobile situation, you potentially get 100 meg of bandwidth coming to you, which is silly. What's everybody ever going to do with 100 meg? Jeez, that's crazy. All right, but at any rate, if you were doing something that had LTE Advanced in it right now, you'd be using it in development. So in other words, you'd be going with whatever standards or documentation really is available, and you might be advancing that, making some assumptions on your own and then taking it back into the standards organization. All right, I think that's it for that. Boop. All right, so this is a reminder. And I think there's actually a little bit of extra information here too. All right, so next week, Tuesday and Thursday, it's your show. So what do I want you to do? So I'm looking for you to have a formal problem statement for your problem, and I'm looking for you guys to have requirement specification for your problem. Okay, two things in your presentation. And there's going to be what? There's going to be 6 teams, so you all get 10 minutes. PowerPoint is made available to you. You can use hand puppets if you want. Doesn't really much matter. It's so that you communicate the information. Yes, sir?
It's going to be a one-person presentation on the whole team.
It's a one-person presentation.
Yes.
Okay?
Great.
I want that person to shine. And by the way, we've got a bunch of these. So I'm getting everybody up here. So pick whoever you want. It doesn't matter. Eventually, I get you all. Okay? And the person who presented the high school crank is not eligible to make this presentation. We'll recycle them later. Okay, so there's nothing to turn in. It all depends on your presentation. You're going to get up here, you're going to present it, we're going to ask you questions. Remember, when you present yours, there's another team that's going to be presenting the same thing. So we're going to be able to do a comparison between the two of you. I know you're going to shine, though. So who's on Tuesday? Who's here from Team California? Woo! Who's here from Team Texas? Team New York? Team Florida? Excellent. Team Illinois? And Team Pennsylvania? Excellent. I would suggest, because Mr. Murphy is alive and doing well, that you select somebody on your team to make the presentation, that you equip them to make a presentation, and that you also pick a backup person and equip them. Traffic can be a bear. We will run through these in this order. We will start with California, Texas, New York, Florida, Illinois, and Pennsylvania. That's the sequence that we will go through these things. Okay? Team California, I need you here right off the bat. I need you ready to go. I need you probably have 2 people ready to do it, just in case the first person doesn't show up. That makes sense?
Yes.
Your future, your destiny is in your hands. Make the most of it. Any questions?
Yes.
All right. Question? That was just a rhetorical question. I didn't actually mean for you.
Is your counterpart on the other day? I assume that it is, right? No, same day.
No, it's on the same day. And it'll actually be, so California and Texas are presenting on the same thing. I would struggle to compare you two. I want to, this is American Idol Survivor stuff, right?
I'm just curious.
Yeah.
So it's like,
It is back to back. It makes the comparison that much easier.
So we're first.
And by the way, I decided that next time we do this, these guys will go on the first day, these guys will go on the second day.
We're going against the same teams.
What's that?
We're going against the same teams.
Probably, yeah.
So if one team's like by far better than the other, you get all the points.
One team's by far than the other. The first time,
Because
I would
Georgia's by
expect to
far
see
much better than
improvement.
North Carolina. So
You know, it's all a grand adventure.
So who's not going What do you want?
It's the real world, man.
Alright.
So do we get like,
It's not-
who want to do law?
What if they don't make it?
We will do vote. Remember, and that's a good point. So the class plays a role in this, not a complete role, but does play a role. And so when we get 2 of you done, I will ask the class who did a better job. We'll just do a simple show of hands.
What if they don't make it to the presentation?
You don't get credit for it. That would be very sad.
Do the right thing.
We'll still do the vote and see if they.
That's
Alright.
the debate.
Good. Formal problem statement, requirement specification. Remember, we've covered it. You know exactly what's in them. You know what the components are. You should be good to go. All right. Capstone. Let's talk about capstone. Where are we in this? So you got a project done. Did everybody turn in the problem statement?
Yes.
So I should have 48 problem statements here. That's fantastic. That's going to fill my heart with joy. Thank you very much for doing that. How was putting together that problem statement? Did that work out okay for you? You feel you know your project a little bit better? All right.
Are you going to be judging us by actual projects we picked or just the content of the way we presented it?
Is this particular homework, is that your question?
Yeah.
I judge you simply on this homework. So you gave me a problem statement. So
Yeah.
I'm just looking at that problem statement and saying, fantastic, you've described the problem you're going to solve. And I know the criteria of what goes into a problem statement, right?
Yeah.
4 or 5 or whatever we listed. I'll be saying, well, cool. In this problem statement, I should be able to answer these questions. I'll take a look at your problem statement. If I can, then congratulations, you met what I was asking you to do. Okay?
Okay.
We've got other stuff. You can see that I'm starting to get interested about having you write a description of your project. I'm not asking you to do that yet. I'm asking you to start to kick that around in your head. Something else I want to ask you about. You did that today, so that's all good. Who's your project mentor going to be? And you know, there's a much bigger question associated with this. Why would they want to work with you? So you know what your capstone project, the one that's kicking around your head, remember you can change it, so there's no problems with that whatsoever. But why would any of the USF IEEE professors want to work with you? Okay? You know, what are you bringing to the table? How are you going to grab their attention? Look, they're busy. They got stuff going on. They'll help you as a charity case, of course. I mean, that's what they got paid for, they're professors. But what is it about your capstone that's going to get them excited about helping you? What's neat about it? Who are you helping? Where's the challenge? Where's the interesting part about your capstone? What's going to make it look different than an electronics kit type of thing? I want you to kick that around. You haven't written your description yet. I want you to think about it. By the way, if you can't answer this, if you can't go, oh, I have no idea why they would want to work with me, then perhaps you might want to change whatever your project is. Remember, throughout this class, you can change your capstone project as many times as you want. It's not going to hurt your grade. It's not going to affect everything. That's exactly what we're trying to do here. We're trying to give you a chance to pick the right one, pick the right horse to ride, as they like to say, right? So find one that works for you. It's going to be important that you find one that works for your mentor also. Okay? Kick it around. Not asking you to do anything yet. Just want you to be thinking about these things. Ethics. Fantastic. Mr. Tannen here, once again, I'd like to point out, dressed very nicely. Okay? That's an expensive estimate. He does look very nice. And once again, if it wasn't exactly for the U.S. Marshals that are leading him away, clearly he would be a very successful individual. Okay? Unfortunately, he also worked for Bear Stearns. I believe he was also involved in that telling people one thing, hey, go ahead and invest in my account, and then internally going, oh my God, this ship's sinking. What are we doing here? Apparently that's highly illegal, extraordinarily unethical to tell your customers one thing when you know something else is true. And so he's going to have a great deal of jail time to think about that. And in jail, I don't think you get the really nice ties. So there you go.
So is he still in jail?
I believe he is. I think they threw the book at him. Not necessarily that what he did was so bad. It's just that the world economy tanked. We were looking for scapegoats. He happened to get caught at the wrong time. He was more of a whipping boy for what went on. So I think they threw the book at him. It could be up to 15. It'll be minimum security, but it'll still be federal.
Yeah, it's actually one.
Does that mean he can escape?
It's a lot of
Well, look, even if he escaped, you think he's got the skills to stay on the lam? He doesn't. He struggles. All right. So let's talk about building an ethical framework because we're desperately trying to do that here. Where are we? We said that you have to recognize when something's an ethical issue. We said you have to get the facts. And we said that you have to evaluate alternative actions. We need to add something to this. Once you've evaluated your different actions, you need to make a decision. But before you take action on a decision, you actually have to test it. How can you test an ethical decision? Well, first off, you consider all the approaches and you say, which one best address the situation that I'm facing? Which is pretty much how you guys make decisions today. It's the second step that'll get you, though. If I told somebody that I respect, or told a television audience, or told my mom which decision I've chosen, what would they say? Okay? Would you be proud of the decision that you made? Mom, I decided to manufacture cheap shirts in China. Get a better value. All right, so let's, as always, let's take a look at some scenarios here. So here's an easy one. So it's references. One of your clients, somebody who's not currently your client yet, gives you a call and asks you a question about one of your competitors. Now, you've heard some dirt about this competitor. You've heard some bad things. One of your other customers had some problems with them. Do you pass that dirt, or shall we call it what it is, gossip? Do you pass that gossip along to this potential customer?
No.
Depends if it's fact.
Yeah, if it's fact, there's no harm. You're not lying to them. You're just basically telling them something that's true.
You know, it's interesting. You don't actually know it's true, though. Right? You know, it's scuttlebutt. Somebody told you something, and you're just passing it along.
But then you wash your hands of it like, well, I thought it was true.
You say what we heard about them.
Yeah, but
Oh, but I thought it was true, right?
Well, he did for me.
But he didn't
Oh, he
do it
did?
true.
I'm sure his lawyer is working really hard on that. So, I mean, you know, so basically, do you pass gossip along? Things that you don't know to be exactly true, but that might help your case.
You let them accidentally find out.
Normally, when you sign up for a job, you have to sign, depending on what type of work you're working on, you know, statements saying that you won't. But I actually had an interview one time where actually it was two different companies, and one of the guys asked me, "Oh, you interviewed with such and such company? What are they working on, by the way?" And I was like, I felt like, oh, I'm trying to get a job here, and I feel like I should tell them. I don't know, but I didn't sign anything.
Maybe it's a test.
Yeah, it was, and I was like, oh no. I kind of
So how
backed
did
it
you-
off, but.
Excellent point. No, and it's a tricky situation.
Yeah.
How did you resolve that? What did you say?
I mean, I said some general topics, but I was like, they didn't discuss too much with me. I didn't really get into detail, but it was just kind of an awkward situation. I felt like he was kind of trying to see how down I was.
I understand.
Yeah.
You're going fishing, so that's a lot. All right. So then, all right, a couple different ways to go. Here's a gratuity one. So somebody's got a big sailing yacht. You're working for a company that does transfers of moves around those big boats and stuff like that. You designed whatever the system was that moved it around. It's you and 5 big guys, and they're pulling it off, and they're doing a tricky maneuver, and they actually get his beautiful yacht from one place to another place, and he goes, "Yay, you're fabulous!" And he pulls out a big wad of $50 bills. What do? Look, you're a professional, right? You're not a waiter or waitress at this particular point in time. Your customer's getting ready to tip you for doing your job. What are you going to do?
Well, depending on if your company allows you to accept it.
If you work at Publix.
Well, you know, generally, in a professional job, that's not something they spell out. I can tell you in my job, it has nothing to do with tips. Thou shalt not accept tips. No, that's, you know, if somebody wants to tip me.
Well, it's just like them taking you out to lunch afterward. I mean, what's the
Yeah,
difference? Except it's money instead of food.
You know, he's a customer, so it's a little bit weird, right? I mean, it's not like he's a supplier trying to get your favor or anything like that. Is there anything wrong with accepting this cash? In the back?
I don't think so, but I wanted to tell you, ask my boss about taking money,
Uh-huh.
and we got work at Tico, and he was saying that if it's below $500, he doesn't have to report it.
There you go.
And at $500, he just has to make it a statement.
So
saying-
there's a tipping point. You know, and that's actually you're exactly, thanks for bringing that up, because you're right. Generally, it's the quantity can have a big impact on what's going on. Right? If you're buying or spending and stuff like that, there's always trip wires built into the system. All right, conflict of interest. So here's a trickier one. So you're hosting some sort of party at the office and stuff like that. Your next door neighbor has just opened her fantastic new catering business, and she's desperate to get it started. She wants to get some reference customers and stuff like that. She comes to you and she says, "Listen, oh, by the way, budget for this thing's $200. That's not that much, right?" She comes to you and says, "Hey, look, I'd love to supply the food for that little event you're putting together. I'll give it to you at cost because I'm just getting started." Okay, what do you think you should do here? Are there any considerations that you have to take into account? Don't know. Are you just gonna give her the business? Why not give it to your mom? Why not go to mom and say, Mom, I got $200 to spend here.
My
Can
mom
you just
can
whip out
order
some
your money.
cupcakes?
Seems like you're getting a good deal.
Perhaps. How do you know you're getting a good deal though?
Shopped around.
She's gonna take $200. Is that the best deal you can get?
You don't wanna get caught into a position where you feel like you have to give her other jobs.
Other than the point, do you have a relationship with her that is beyond a professional relationship?
It's not saying.
She's your neighbor,
You didn't say she was
right?
a
She's a friend. And you'd be giving a friend business, right? Does that make it a little bit of wiggling? A little tricky on that one? I mean, is there an issue here? Maybe there's no issue.
It's usually not a good business.
It's only $200. Maybe, maybe because it's not a lot of money, it's okay.
Well, it's just a friend that's doing a service.
Right,
It just happens to be a friend, they're still providing
That's true.
a service. So what's the-
And it's traffic, you never.
Well, here's an interesting question. Say I'm somebody else who provides a similar service, and I see that you give her the business. Can I go complain?
That's just too damn bad, I mean,
You
can.
you have the right to choose what you want to
It
do.
doesn't seem like I got a shot at it.
For lunch, it's one thing.
Well, and you can scale this up too, right? I mean, so this is, but it brings up an interesting point. I mean, this is a fairly trivial example. I mean, it's not that big of a deal.
Well, that kind of is,
A
that
lot
is
of
kind of
times
the
you
case.
have-
That's
You can
what's
scale it
happening.
down too. I go to a restaurant because my friend's working there sometimes. It's like, I mean, it's
That's not really fair to your friend.
no, it's like oh, you could have gone to Chili's with Applebee's. Why'd you go there? It's like it's not really.
At the end of the day, you
So
don't
do
want
you
to know.
talk friends into going along with you to the restaurant where your friend works?
No, I go eat alone.
I was gonna say-
Absolutely. Sad lonely boy stuff. That's
Feedback is
for us.
somebody that you personally know. So like if it's somebody that, like your neighbor that's doing the service for you, and they ask you how you did, how do you honestly answer them, no, it was horrible, and the next time something comes up for them to have a possible job, well, I did good last time, you said I did good, so why can't I have a job?
There you go. And so, independent of the ethical issues, you open up a can of worms here, right? Because she could blow it. She might be the worst caterer ever, right? And by the way, she lives right next to you, right? Forever. So,
Well, next time.
so here you go. This might be along the lines with some of the other stuff that Mr. Samuel bumped into. Okay, so you're in a head-to-head battle with your arch competitor, Evil Enterprises, which of course indicates that they're bad.
They're evil.
Okay. One of your coworkers approaches you. It turns out he worked for them. Okay, and what he says is that he took good notes, basically. He made notes on all their bids, and he can get the data for you. They have some clear cost standards. So what that basically means is that he knows what they're going to bid, what price they're going to use when they bid on a contract. And knowing this means that you could make your price lower than theirs, right? He says, hey, look, I can bring my notes to the office tomorrow, and we can go ahead and look through them. So what did you say?
Did he sign anything with the other company?
Let's assume no. Let's assume he did not sign anything. So he's not breaking the law.
So if you're not breaking the law, then there's no law.
Okay, so let's go back to what we talked about today. What did we talk about today? Make a decision and test it. So let's go, stay with me here. Hey, Mom, there's this guy in the office who had secret inside information about a company that I'm competing with. And so we decided to have him bring in his secret information so that we could underbid them on a proposal that we're working on. And Mom would say,
Good job, son.
No, I didn't do the work.
question there, sir.
She might not be illegal for him to bring the information. but it will
Hey,
be
everybody,
illegal-
quiet for a minute. Sorry, what's that again?
It might not be illegal for him to have the information because he walked away from the company without signing, but it will be illegal for you to use it.
Wait, so the information is illegal for him to have, but it might be legal for you to use?
If you use the information,
Oh, the other way around. The other way
I'm going to leave it there. If you happen to find it, that would be just
terrible.
You're on a tricky ground. Okay?
Are we saying there's no, if there's no legal issues, like if you did this, the only thing that would happen is that you would turn a profit?
Why not?
You would get away with it.
No, you wouldn't, if it was legal, there's nothing to get away with. You just,
Okay, but wait, he has secret inside information. So if you called up Evil Enterprise and said, hey, by the way, can I have your cost information? Because I'm working on a bid against you, would they provide it to you?
they wouldn't.
He's got secret confidential information.
But again, the key phrase here is illegal, and if the answer is no.
No,
then
Scott, is it ethical?
Is it ethical? That's the.
Come on, Scott.
All right. So what did we cover today, guys? We talked about marketing and engineering requirements. We pointed out that there's a relationship between them. We talked about mapping one-to-one, one-to-n, M to N.
Gentlemen,
We talked about your engineering and marketing trade-off matrix. We talked about your engineering trade-off matrix. We talked about the house of quality. We talked about competitive benchmarks, house of quality. I asked you to start to consider who's going to be your mentor. If you can't answer that question, or if you can't answer it satisfactorily, I want you to be thinking that maybe it might be time to change the project. We talked about ethics, make a decision and test it. Next week, the best week ever, in-class presentations. Formal presentation of your problem statement, requirements for your problem, nothing to turn in, it's all based on your presentation. You can use PowerPoint if you want. We know who's presenting on Tuesday. Have a fantastic weekend. I will see you next week.